Moving on to question number 5. Okay, now you can see we've actually moved into the intermediate section of the questions, because now I'm giving you an equation that has two kinds of functions. There's a cos on the left hand side and a sine on the right hand side. Okay, you need to get these functions the same by any means necessary. Okay, right now the easiest way to get them the same is simply to change sine into its co-function, which is cos. So sine 60 degrees is the same as cos 30 degrees. Okay, what happens here now is the causes cancel out and you end up with an answer in the first quadrant where our angle 4 theta minus 10 degrees is equal to our reference angle here, which is 30 degrees. But remember, cos is also positive in the fourth quadrant, so I need to write out another solution. Okay, let's start out with our angle again, 4x minus 10 degrees, and that should be equal to 360 minus our reference angle, 360 minus 30 degrees. Okay, now we can actually solve our equations. I will simply add 10 degrees to both sides, and then I'll divide by 4, and so that gives me theta equal to 10 degrees. Now remember, this is cos, so normally I would say plus k 360. However, since we divided by 4, this now becomes plus k 90 degrees. K an element of z. Okay. Let's do the same thing on the other side. So I'll add 10 degrees to both sides, and that should give me 340 degrees, if I'm not mistaken, right? And then I'll simply divide by 4 on both sides, but I don't know what the answer for this is, so let me check. 330 minus 340 divided by 4, and that's 85. Okay, that was pretty easy. Guess I was just too lazy to think. Plus k 90 degrees. Again, 90 because we divided everything by 4, including the 360. Right. So that's it for question number 5. Not too bad, eh? Question 6. We have to do the same thing over here, right? We need to get the functions the same. Here's a sine on the left-hand side, and there's a cos on the right-hand side. So we're going to make use of a co-function, which will change the cos of 2 theta into sine of 90 minus 2 theta. Okay, if you don't know this relationship, make sure you go and study co-functions. Okay, co-functions, or also known as co-ratios. Okay, so go and study this. Right. Now I can simply cancel sine on both sides, and in our first quadrant we'll have our angle, which is theta plus 30 degrees, and that would be directly equal to the reference angle, which is 90 minus 2 theta. However, there are always two solutions for sine and cosine. Now sine is also positive in the second quadrant, so when we take our angle again, theta plus 30 degrees, that must be equal to, in the second quadrant, it's 180 minus 90 minus 2 theta. Okay, I've managed to squeeze it in over there. Okay, now let's solve theta for both sections. Right, on this side, we'll add 2 theta and we'll subtract 30. That should give us 3 theta equal to 60 degrees, and therefore theta equal to 20 degrees. Let's not forget, we started out with plus k 360 because it's sine, but since we divided by 3, right, you see here we've divided by 3, we also need to divide 360 degrees by 3, and that leaves us with 120. And now on to the second part of this equation. Here we'll, I guess, let's first simplify the left hand side there. So that's going to be 180 minus 90, so that's just 90. And then negative times negative gives us positive 2 theta. Bring the 2 theta over to the left hand side by subtracting. Also subtract the 30 degrees. And then that gives you negative theta equal to, what is this? 60 degrees. Right, now for this one, theta is going to be equal to negative 60 degrees, but we haven't divided by any number, right? We haven't divided by like 1 or 2 or 3 like in previous cases. So here, we're still going to have plus k 360 degrees. And you don't have to say minus k 360 degrees, because maybe you're thinking, didn't I divide by a negative sign? It doesn't matter, because k is an element of all integers, both positive and negative. And so you don't need to write minus k 360, right? You can just leave it as plus k 360. The fact that it's an integer means all of those things. Right. Similar scenario in this case. We're going to find a co-ratio. So I want you to think about, what will I change the sine theta into? Sine theta will become cos 90 minus theta. Okay, and now you can simply cross out the cos thetas on both sides and continue solving, right? Cos is positive in the first quadrant, where your angle is equal to the reference angle. And it's also positive in the fourth quadrant, where your angle is equal to 360 minus your reference angle. Okay, again, limited space here, but I'll try and squeeze it in. Okay, now let's continue solving this. Add theta to both sides, and also add 15 to both sides of the equation. This simplifies to 3 theta equal to 105 degrees. Therefore, theta is equal to 35 degrees. This time plus k 180. I mean k 120, because we divided by 3. Let's do the same thing here. I'm going to simplify by subtracting 90 from 360. That becomes plus theta. When you take it over, 2 theta minus theta, and then 270 plus 15 degrees. Okay, therefore theta is equal to 285 degrees. This time we didn't divide by anything, so your final answer is actually just plus k 360. Okay,